Good morning everyone, I am Arijit. I am a researcher in physical history laboratory. Now you may be wondering why I am holding this football in my hand. So if you ask a scientist what is football, according to the scientist he will tell definitely there is a molecule known as Buckminster fullerene, and in 2010 the molecule discovered in interstellar space, you can find it is there. So our objective is to find out how fullerene grows in those extreme harsh conditions. So let me tell you how. So here you can find in Earth we are generating this interstellar harsh condition in our lab, and let me show you how. In background you can see the Spitzer IRA spectra of the Planetary Nebula TC1. Here the red spots or red dots are showing the presence of this particular molecule in space, and the blue dots are representing an elongated or slightly larger football-like molecule present in the space. So black spectrum you can see here, this is the observed spectrum, and that spectrum was very well fitted with the laboratory spectrum of this particular molecule known as fullerene. So now question is, in this particular spectrum there is no signature of hydrocarbon. So how this particular molecule grows up or synthesizes in interstellar space, that needs to be investigated in lab. In tisular spectrum we have already seen this, there is no hydrocarbon or polycyclic aromatic hydrocarbon signature present. So if you want to synthesize fullerene irrespective of hydrocarbon route, so better start with the amorphous carbon, which is hydrogen free. So this amorphous carbon you can easily get in your home also, where you burn wood or some sort of hydrocarbon. Now if this amorphous carbon exposed to the shock condition, what will happen with it? So to understand its fate, we use this particular instrument which is known as high intensity shock tube for astrochemistry, or HISTA. This particular instrument can generate shock waves more than 6 times velocity of sound, and temperature goes up to 7000 Kelvin. So if you expose this particular substance, amorphous carbon, to the high intensity shock, what will be its fate? Does it only make the fullerene or something else? Let us investigate. So when we subject this amorphous carbon to the interstellar shock condition for 2 milliseconds, we get fullerene as well as a lot of other carbon nanostructures started from carbon nanotube, graphene, carbon nanocone, and carbon nanoonions. So we have zoo of carbon nanostructures with fullerene. So now we are getting back to the astronomers, telling them that not only you have to search fullerene in those shock process regions, but you have to search for other carbon nanostructures too. And here is my PhD problem is, I am working on it.